Hello, ma'am. Myself Vineet. I'm from CSCH, bearing pin number 806. I'm going to explain about 8086 pin diagram. In 8086 pin, there are totally 40 pins, in which 32 are common pins and remaining 8 are either maximum pins or minimum pins. From AD0 to AD15, these are address data lines, and these are of 16 bits. And NMI and INTR are interrupt pins. NMI is a non-maskable interrupt, and the request must be serviced. And INTR is a maskable interrupt, like it can be request can be ignored. And clock pin is used for synchronization purpose. PHE is a bus high enable. This says when this pin is active, the data lines are active. Like RT bar is a read pin and it's active low pin. When this is active, that is when this is 0, the data can be read from input devices. And maximum minimum pins are divided into two parts, like both are 8, and minimum pins are hold, HLDA, WR, that is write, memory input output, data transceiver or receiver, data enable or address latch enable, and interrupt acknowledgement. Hold pin is used when direct memory access asks the CPU for control over the bus. Then hold pin is active, and when CPU gives control of bus to the DMA, that is direct memory access, then then HLDA pin, that is hold acknowledgement pin, is active. WR, that is write pin, is an active low pin. When it is active, data is transmitted into the output, like it can be print to the output. DEN is a data enable. That means that data is ready in the bus, and data transceiver or receiver means data is ready in the bus, and if data transceiver receiver pin is active, that is if it is 1, then data is to be transferred, or if it is 0, then data is received. Memory or input output pin is when it is 1, then the data transceived is into the memory or received in memory. When it is 0, then like data is transferred into the output devices or received from the output devices, from the input device. ALE is an address latch enable. In address data lines, when ALE is active high, address lines are active or enabled. INTA is a active low pin. When INTR and INTA pins both are active, then INTR request can be serviced by the processor. And now maximum mode pins are request grant not, request grant 1, lock, S2, S1, and S0, QS0 and QS1. Request grant not is a maximum mode is used when there are multiple processors. Like if one processor is asking another processor for control over the bus, then it sends a request and if the processor which is having the system bus, if it grants that and it gives the system bus control to that processor, then the request grant pin is enabled, and that is, it is active high. And when both processors are asking at the same time for the system bus, then the processor with request grant not is having more preference than the request grant 1. When the lock pin is enabled, the control over the system bus is prevented from that processor. S2, S1, S0 are status pins, like when they are all active low, that's when they are all 0. Sorry, they're all 1s. they're inactive. When they're all zeros, that is when they're all active, then it is a interrupt act. If there is both are S2, S1 or 0, 0 and S1 is 1, then input output rate is operation is going on. So like that, there are some different operations, some 7 different operations. QS0 and QS1 are status of instruction queue. Like when the both are 0, 0, like there is no operations going on. Like QS0 is 1 and QS1 is 0, then it is an empty queue and so on. Test pin, it is an active low pin. When it is active, then the execution of instruction is going on, like continuously going on. And when it is inactive, then it will be in a wait state. Ready pin is an active high pin. When it is active, it indicates that data is ready to be transferred. Reset pin is an active high pin. When it is active, that all the registers are emptied and all the registers are set to like initial state. Thank you, ma'am.